Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve next question. Question number 14, NEET Physics paper 2014. So let us solve the question. Students, let us solve the question number 14. A certain number of spherical drops of liquid of radius r, certain number of spherical drops of liquid of radius r coalesce to form a single drop of radius r. Means so many smaller droplets, okay, so many smaller droplets combine to form a single big drop. Each of these small droplets have radius equal to smaller. This one bigger one is having radius capital R. The volume and volume V, this is having volume V. So the volume will remain same during this process. So one thing is sure, that the volume is constant in this transformation. If T is the surface tension of the liquid, T is the surface tension of the liquid, then which one of these four options is correct? Basically, it talks about the energy released or energy absorbed, or neither energy released or absorbed. So it's talking about basically energy. So when you find energy, then only you can find the answer. So we know that in this process, the surface area actually decreasing, because this has a greater surface area than this. So that means actually energy is being released. So that is clear. So 1 or 3 might be the answer. Now, how much energy is released, that we are going to find. Because the area is decreasing, so energy from more area to less area, the change in area is negative, so energy is released. If this R is more than this R, that means the energy is released. Anyway, energy is released, so out of this, so 2 cannot be the answer, 4 cannot be the answer. Now, what I'll do, I will just write the formula for the energy released or absorbed. The formula is same, that energy is T delta A. That is the work done in this process. How much work is done, that is the work done. That's the energy. And surface tension T, and this is the change in area, that is the final area minus initial area. I know that energy is released, so I will not write this minus this. I'll directly write this minus this, because I already told you that the energy is released. So what is the surface area of this part, first one, and what is the surface area of the second part? Change in area is actually final area minus initial area. That way if I go, then even if I take the mod of that, I know that this is released, so I can take this minus that. So if I do that, then I have this situation, 4 pi small r square in n number of droplets minus the, I'm just taking this minus this, because I know that this is greater. If I take this minus this, finally it will be negative. That means the energy released. Otherwise I'm just doing that in positive answer. Final is 4 pi r square, that is single drop multiplied by 1. This is how the area is changed from initial value of this to final value of this. So I can write minus of this, because if I approximately write that, this will be minus actually. and that minus minus becomes plus. So if I actually am going to apply this, then I'll write minus, no problem with that, minus of t. 4 pi out, and this is r square n minus 1. Sorry, this is r square. Now next is we have to find the relationship between this small r, capital R, and we see the options. In the options we have to write in terms of small r, capital R, both have to be present, and v and t have to write. Okay, now leaving the negative sign, because that implies release of energy. I'll just write the positive value of that. The energy released equals to 4 pi t bracket r square n minus r square, that we discussed last time, and during this process the volume will remain constant. So from one conversion to another, from so many droplets to a single droplet, the volume will remain same. Earlier the volume was n times, because n number of droplets. Each droplet has volume equal to 4 upon 3 pi small r cube, and the single largest drop that is formed has volume 4 by 3 pi of capital R cube. So from here I have the relation that n becomes, if I don't want n in the expression, because finally the answer doesn't contain n, so I have to eliminate n, and that n becomes r cube over small r cube. From here, substituting that value here, 4 pi t r square, n becomes r cube over r cube minus r square. Okay, so this r square can I take outside, because I don't want r square here, because if I see the options, this is actually the answer, then I have to just arrange it in this form. I don't want any value here. I'll just take it outside, and this would be small r, capital R. In that way, this r square cancels out, and this becomes r. So 1 over r is there. If I take r square out, or r cube out rather, 4 pi t r cube out, this is 1 over r minus 1 over r. This is the form that I'm getting, because this r square is there. 1 r I multiply here, and 1 r I divide here. Multiplication of r gives you r cube. That goes out, 1 r is left. Now, this part is looking clear, that it should be 1 by r minus 1 by r. That is clear, but that also there in both the cases. Now you want 4 VT or 3 VT. You can see that it's 3 VT, that's 4 VT or 3 VT. Let us see what is that. V is the volume, which is 4 over 3 pi r of Q. To have or to introduce V in this expression, I will find this expression 4 pi r cube. 4 pi r cube is there, but 3 is not there. So I'll just divide 3 and multiply 3 here. Now this 4 by 3 pi r cube will become V. So this will become 3 V and T. So this will become 3 V and T, and this is 1 over r minus 1 over r. So 3 VT, 1 over r minus 1 over r. This is the option number 3, which is correct. Okay, thank you.